When you ask someone to draw a star, they'll probably draw something like this, or this, or this. Even ignoring the rainbows, this doesn't seem very scientific, since we know stars are actually big, hot, round balls of plasma and far enough away that they're basically just dots. So why do we draw stars that have points? The answer is surprisingly simple. We see stars as pointy. Look carefully next time you're outside on a dark night, or just look at this dot. It works best if you make the video full screen, close one eye, and relax the other as if you're looking at something far away. You should see a pointy star-like shape. In fact, it's not just humans that see pointy stars. Some telescopes see them that way, too. This is all because light is a wave. When light from a distant source passes through an opening or around an object, its waves are bounced or bent slightly and interfere with each other, so the passing light picks up an imprint of that opening or object. A straight line, whether it's a slit letting light through or a rod blocking the light, leaves its imprint by spreading the light out into a perpendicular series of dashes, like what you see when you squint. A cross creates two crossed sets of dashes, circles cause concentric rings, squares spawn a kind of dashed four-pointed star, hexagons dashed six-pointed stars, and the famous double slit experiment gives a series of dashed dashes. My favorite diffraction pattern, though, is probably that of the Penrose tiling. It's simply gorgeous. Not that you see Penrose tiling-shaped openings very often, but the point of all these imprints is that they're the result of a point of light being spread out when viewed through a particular opening or past a particular object. For example, the Hubble Space Telescope has 4 struts that support its small secondary mirror, and their imprint causes the 4-pointed stars in Hubble photos. And I bet you can guess the shape of the aperture in the lens that took this picture. Similarly, the lenses of our eyes have subtle structural imperfections called suture lines, where the fibers that make up the lens meet. These imperfections leave a very particular imprint on light as it passes by, as researchers have confirmed by shining lasers in people's eyes. So even though stars themselves are just tiny round dots, by the time the light reaches our retinas, it's been smeared out into a star-like shape. Every single eye on Earth will see a slightly different star-like smear, depending on the exact nature of its suture lines. Even your own left and right eyes will differ. What's weird, though, is that any particular eye sees the same star shape for every star. So while it's actually scientifically acceptable to draw stars like this, if you draw more than one in a single picture, you better make sure they're all the same shape. On top of that, since diffraction spreads out longer wavelength red light more than bluer light, the arms of these star shapes are actually mini rainbows, with red on the outside and blue towards the middle, which again you can see in Hubble photographs, or if you look even more carefully at a single point of light. So as crazy as it sounds, coloring in stars with rainbows is super scientifically accurate, as long as the colors go the right way.